Hello Bobcats. Today we are going to discuss solution concentration in this video. So to discuss solution concentration we need to make sure we go over a few definitions. First we need to recognize what a solution is, and a solution is a homogeneous mixture of two or more substances consisting of ions and or molecules. And remember, if we have an ionic compound and we dissolve an ionic compound in water, it dissociates into its separate ions. And because of that, we can say that that solution contains electrolytes. Ions are electrolytes because they can conduct electricity when dissolved in water. Or we can also have molecules that dissolve in the solution, and those molecules, such as sugar molecules, do not have ions, they don't have a charge, but they do dissolve in water because they are polar, and water is polar. We also have the solute. The solute is a substance being dissolved in a liquid. It is the least amount. Then we have the solvent. It is the liquid substance that is dissolving the solute. It is the largest amount. And then we're going to be talking about concentrations. Now, concentration is the amount of solute dissolved in an amount of solution. So again, concentration expresses the quantity of solute given in a given quantity of solvent or solution. So we have two types. We can have a concentrated solution or we can have a dilute solution. If the solution has a relatively large amount of solute per volume of solvent, that is considered concentrated. If the solution has a relatively small amount of solute per volume, we say the solvent is, or the solution is, dilute. So you have concentrated and dilute. Dilute has a small amount of solute per volume of solvent. Concentrated is a large amount of solute per volume of solvent. Now, there are several different ways we can do concentration. We can have concentration as a mass concentration or volume per volume concentration. There's concentrations parts per billion, parts per million. We can also say concentration in molarity or normality, but we are going to discuss concentration is molarity. And molarity, if you can recognize the word mole, we're going to have a mole in it. So molarity, represented with a capital M, is a type of concentration defined as the moles of solute per liter of solution. So we can say molarity is moles of solvent per liter of solution. A lot of times I just write a capital M representing molarity is moles per liter. And remember, that's the moles of what's being dissolved in a liter of solution. The unit for molarity is a derived unit. Okay, that means that it's has two direct measurements in it, moles and volumes here, and so we can use that as a conversion factor to go from moles to liters and back and forth. But we represent it with a capital M. So again, it's a unit derived, it's a derived unit. We call it molar, and it's symbolized with the capital M. So when I see it written like this is a concentration of a sodium chloride solution, but we would say 2.25 molar concentration of sodium chloride in solution. That's how I would say it. We don't say 2.25 molarity, we say 2.25 molar concentration of sodium chloride solution. But remember, this capital M really represents moles per liter. Okay, so we're going to look at we're going to do some practice problems together to make sure we understand how we determine molarity. Now, if you need to write any of this down, remember you can stop the video and write the notes. I just wrote them beforehand so that I don't have to spend time writing them in this video. But we will do the practice problems together. So let's get started. We'll call this calculating molarity. And we're going to do 3 practice problems in this. So in the first problem, the problem is going to be, what is the concentration of a solution that has 12.3 grams of copper 2 chloride in 250 milliliters of solution. Okay, so if you notice here, we have a mass of copper 2 chloride and we have a volume of solution. So, and concentration is in molarity. Now, when I do a problem like this, I'm thinking, okay, I want to know the concentration, but really concentration is looking for moles per liter. That's concentration, that's molarity, right? Capital M. And in this case, we're looking for moles of copper 2 chloride. So moles of copper 2 chloride per liter of solution. Copper 2 chloride is what is being dissolved. That's the solute. So again, I'm going to start with my mass. So I have 12.3 grams of copper 2 chloride. And I have to go from mass to moles. So I'm going to use molar mass. So 1 mole of copper 2 chloride has a mass of 134.45 grams of copper 2 chloride. Okay, that's the molar mass. 1 mole is this mass. So now I can cancel the mass. Now I have moles on top, and I have moles on top here. What I'm missing is a volume unit. Well, the volume unit that I have is 250 milliliters. So I'm going to put that on bottom, 250 milliliters. The thing is, I don't want milliliters, I want liters, so I got to do a conversion factor. And that's going to be, for every 1,000 milliliters, I have 1 liter. So now my answer, when I calculate it all, says that it'll be 0.366 molar solution of copper 2 chloride. Remember, when I did the dimensional analysis, I'm really looking for units of moles per liter. So instead of writing capital M, I write moles per liter. But when I get my answer, I'm going to write it with the capital M and say 0.366 molar solution of copper 2 chloride. Now, eventually, you guys will not have to do this kind of conversion. You'll just convert in your head this to 0.250 liters, okay? So we can skip a step like this. The next problem, and what I mean by that is that instead of writing this whole thing out, I could have just written 0.2500 liters on the bottom here, and that way I would have had the liters. So you should be able to convert milliliters to liters and back and forth. If I go from milliliters to liters, I have to move the decimal place, just the decimal 3 places. So eventually you can get rid of this extra step here by just writing it out like this. Okay, now the next question, let's look at the next one, number 2. So with number 2, this one I'm looking for concentration in the first one. In number 2, I want to know how many grams of sodium chloride are in 35.0 milliliters of a 2.50 molar solution of sodium chloride. So you notice I don't write solution or anything. When I write that capital M, that means I'm dealing with the solution. And the concentration is 2.5 molar, or 2.5 moles of sodium chloride per liter. So I'm going to go ahead. Now I notice here that my information, I've got 35 milliliters, and I have a concentration of 0.25 molar. What I really need to think about here is, if you can think about this, what if I would have a bottle of sodium chloride that is 2.5 molar concentration, and if I pull out a 35 ml sample, how many grams of sodium chloride would be in that 35 ml sample when this is the concentration? So let's do the problem again. In this case, I'm looking for grams of sodium chloride. So I want to know grams of sodium chloride. Now I'm going to start, if you have to decide which of these values to start with, remember this is a derived unit, so we don't start with derived units if we can avoid it. We start with a direct unit, and that's the volume here. Now we have to remember that molarity is moles per liter, which means I need to convert this volume from milliliters to liters. And if I do that in my head, I'm just going to move my decimal 3 places. So that's 0.0350 liters. That's 35 milliliters. Now that volume has a concentration, so that would be 2.50 moles of sodium chloride per liter of solution. Now remember, moles per liter is molarity. So the liters cancel. I don't want moles of sodium chloride, I want the mass. So to go from moles to mass, I've got to use molar mass. So in this case, 1 mole of sodium chloride has a mass of 58.44 grams of sodium chloride. That's molar mass, grams per mole. Okay, so the moles cancel, I have grams, that's what I'm looking for. So when I multiply across the top, I'll get 5.11 grams of sodium chloride. So if I take this 35 milliliter sample and I evaporate all the water, I will get 5.11 grams of sodium chloride when there's this concentration of it. If you're having trouble thinking about it, the way I think about it is, well, maybe you guys don't do this anymore, but when I was a kid, we made Kool-Aid, and you can make really, really sweet Kool-Aid by adding a higher concentration of sugar. So remember, concentration just means you have more of that substance in it, or how much of that substance you have in a volume. Now, the last one that we're going to look at here for calculating molarity, the question will be number 3. So if you'll notice here, we looked at concentration. Here we had to find grams. The last one, of course, is going to be determined the volume. So what volume in milliliters of a 3.40 molar concentration of aluminum sulfate has 24.6 grams dissolved in it. Okay, so now what we have here is we have a concentration and we have a mass, and we're looking for volume. Let me go back. Oops. Oh, darn it. Hopefully this is still going, right? Man, that was close. Okay, so this up here we were looking for grams when we had volume and molarity or concentration. Up here we were looking for concentration when we had grams and volume. Now we're looking for volume when we have concentration and mass. So again, what we do is we look at this and we go, okay, I'm going to work on this. I'll start with my question mark. I'm looking for volume in milliliters. And I need to know, I want to start with my direct measurement. Remember, molarity is a derived unit, which can be used as a conversion factor. So I'm going to start with 24.6 grams of aluminum sulfate. Now, we know that molarity has moles per liter, so I've got to convert grams to moles. So I'm going to use molar mass. So 1 mole of aluminum sulfate has a mass of 342.14 grams of aluminum sulfate. That's molar mass. Okay, so I can cancel my grams and now I have moles. But I don't want moles, I want volume. Now my mole to volume conversion is molarity. Remember, that's moles per liter, so that's moles to volume conversion. So if this is moles per liter and I get moles on top, that means I need to put 3.40 mole of aluminum sulfate per liter. Okay, so again, moles per liter is molarity. That's this capital M, moles per liter. But in this case, I had to put the moles on bottom because they were on top here. And the last thing I need to do, the moles cancel, is I got to convert liters to milliliters. So we know that 1 liter is 1,000 milliliters. And so I multiply 24 times 1,000 divided by 342.14 divided by 3.40, and this will give me 21.1 milliliters of solution. Okay, so those are the different ways to use molarity. The next thing is, so that's making solutions and knowing the concentration of those solutions. But a lot of times in chemistry we buy what are called stock solutions. Those are solutions that are already concentrated, especially when we deal with acids. And so when I go to buy like hydrochloric acid, I purchase it in a stock solution of 12 molar hydrochloric acid. Now 12 molar is very, very concentrated. So we buy that stock solution, and let's say in a reaction I don't want 12 molar, I want 1.2 molar. So I have to dilute the 12 molar down to 1.2 molar. And so there's an equation for dilution. And that's what the last part we're going to talk about in this video today. So let's go through and talk about dilution. So if I am going to do dilution, we have an equation for dilution, and that equation is going to be the molarity of the concentrated solution times the volume of the concentrated solution is going to equal to the molarity of the dilute solution times the volume of the dilute solution. So let's go ahead and write what each one of these are over here. So MC is equal to molarity of concentrated solution. VC is volume of concentrated solution. MD is molarity of dilute solution, and VD is volume of dilute solution. Okay, so this is my equation, and just to remind you, if I see something that says stock solution is a concentrated solution. So stock solution is the concentrated solution. Okay, so here's my information. Let's do a problem to check, to make sure we can do this. So our practice problem is going to be, what volume in milliliters of a 2.00 molar solution of calcium chloride, stock solution, so 2.00 molar calcium chloride stock solution, so that means that's the concentrated solution, would you use to make 500 milliliters of a 0.300 molar calcium chloride solution? Okay, so when I go through this, I realize that I am looking for a volume. That volume is going to be the volume of the concentrated. This is the molarity of the concentrated. This is the volume that I want to dilute to, so that's the volume of the dilute, and this is the concentration that I want, so that's the molarity of the dilute. So now I write the equation. So we have MC VC is equal to MdVd, or volume of dilute. I'm looking for this one, so I'm going to divide both sides by MC. So V, the volume of the concentrated that I need to dilute will be the molarity of the dilute times the volume of the dilute over the molarity of the concentrated. So now I just substitute. So we have the molarity of the dilute, that's this one right here. So it's 0.300 molar times the volume of the dilute, that's 500 milliliters. Now, I didn't have to convert to liters, because remember, if I'm in milliliters and I'm looking for milliliters, I do not have to convert to liters. And the other reason I don't have to is because the molarity is used in both here, so I take care of that unit of liters with molarity. So molarity cancels, I'm left with milliliters, and so this answer comes out to be 75.0 milliliters. Now what this means is that in order to get a volume of 500 mils, in order to get a volume of 500 mils, you would add 75 milliliters of the 2.00 molar calcium chloride solution, stock solution, to 425 milliliters of water. That gives me the 500 mils. Or you can say, I'm going to put 75 milliliters of this concentrated solution into a 500 milliliter volumetric flask, and then add water up to the 500 mil mark. Okay, and that's dilution. So this is a concentration of molarity. The next thing we're going to be talking about would be solution stoichiometry and concentration of ions. And that's this video for today, and thank you very much.